Hi students, welcome to Future Doctor Neet Academy for the problem solving session in Neet Physics. But today we are not going to solve the problem. We are going to give only the questions for the problems. 7 problems will be given, and in next session the problem will be solved and solution will be discussed. Topic chosen today is from chapter 6, electromagnetic induction. We will move to question number 1. A coil of 800 tons, effective area 0.05 meter square, is kept perpendicular to a magnetic field of 5 into 10 power minus 5 T. What is T? Tesla, which is a unit of magnetic induction or magnetic field. When the plane of the coil is rotated by 90-degree angle around any of its co-planar axis in 0.1 second, the EMF induced in the coil will be dash. A option 0.2 volt. B option 2 into 10 power minus 3 volt. C option 0.02 volt. Last option 2 volt. So here you want to find EMF induced. Let's move to question number 2. A coil of resistance 400 ohm is placed in a magnetic field. If the magnetic flux phi, which is in Weber, linked with the coil varies with time t, which is in second, as phi equal to 50 t square plus 4. The current in the coil at t equal to 2 second is dash. A option 0.5 ampere. B option 0.1 ampere. C option 2 ampere. Last option 1 ampere. So here you want to find a current with respect to resistance and magnetic flux. Let's move to question number 3. A conducting circular loop is placed in a uniform magnetic field B equal to 0.025 Tesla with its plane perpendicular to the loop. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. The induced EMF when the radius is 2 centimeter is dash. A option 2 pi microvolt. B option pi microvolt. C option pi by 2 microvolt. D option 2 microvolt. Here you want to find the EMF induced by changing the which one? Area of the coil or orientation? Yes, area of the coil. Okay, let's move to question number 4. Fourth question. A rectangular coil of 20 turns and area of cross section 25 square centimeter has a resistance of 100 ohm. If a magnetic field which is perpendicular to the plane of the coil changes at a rate of 1000 Tesla per second, then the current in the coil is dash. A option 1 ampere. B option 50 ampere. C option 0.5 ampere. Last option 5 ampere. Here also EMF induced you want to find. From that you can find a current with respect to resistance and 1000 Tesla per second. It means here change in the magnetic field per unit time. Next we will move to question number 5. Fifth question. A magnetic field of 2 into 10 power minus 2 Tesla acts at right angles to a coil of area 100 centimeter square with 50 turns. The average EMF induced in the coil is 0.1 volt when it is removed from the field in t second. The value of t is dash. Option A 10 second. B option 0.1 second. C option 0.01 second. Last option 1 second. Here you want to find time only in second. Next question, question number 6. A conductor of length 0.4 meter is moving with a speed of 7 meter per second perpendicular to a magnetic field of intensity 0.9 Weber per meter square. The induced EMF across the conductor is dash. A option 1.26 volt. B option 2.52 volt. C option 5.04 volt. D option 25.2 volt. Here also you want to find induced EMF only in volt. Next question, last question of this session. Seventh question, the magnetic potential energy stored in a certain inductor is 25 mJ. What is mJ? J is a joule, mJ means millijoules. When the current in the inductor is 60 mA, what is mA? mA is milliampere. Then this inductor is of inductance dash. That is, you want to find the inductance of the coil. Option A 1.389 H. What is H? H is the unit of inductance Henry. And B option 138.88 Henry. C option 0.138 Henry. Last option 13.89 Henry. So before applying this millijoules and milliampere, you want to convert into normal joules and ampere, and then you can apply. So in next session, we are going to discuss the solution of this problem, that is how to solve this in a simple method. Okay, thank you students.